Okay, section 7.4, day 2 notes. Essential question: how do you find the asymptote of a graph of a logarithm just by looking at the equation? This section will be graphing logarithms. Pretty much logarithms are the inverses of exponential functions, so they're going to have some of the same characteristics except for backwards. Okay, as you can see on this one, g of x equals b to the x and f of x equals log base b of x are inverses of each other because they reflect over that y equals x line. So remember when we did b to the x, how the asymptote was always y equals 0 or y equals a number, and our domain was y is greater than 0. Well, when we graph logarithms, the inverse changes. So now, like the inverse of this one would be x equals 0, or the asymptote would be x equals 0, and the domain will be x is greater than 0, okay, because you can't take the log of 0 or a negative number, okay, as x. So that's how it changes for the log, and you'll see that on the graph. And you can also see how, if it's a decay function, how it rises differently from there as well. Um, so let's get to graphing now. Okay, so one way to graph this, if you want to do this by hand, and it's a simple one, I'll also show you how to do it in the calculator, but how you can do it is rewrite it in exponential form and then do your table backwards, okay? So however you write this in exponential form is 3y to the x, okay? Now I'm going to make a table, okay? Except for instead of starting with my x's first, I'm going to start with my y's, okay? So I'll do a y like -1, which 3 to the -1 is, and I start with my y's because I don't want to do 3 to that power equals x. So I'm working backwards here. So I start with my y and then go to x. So 3 to the -1 is 1/3. So y -1, x is 1/3, okay? Then I go to the next one. Let's do 0. 0 is the easy one because anything to the 0 power is 1. 3 to the 0 power is 1, okay? Then we go to the next one, which is 1. 3 to the first power is 3. And then we go to the next one, and 3 squared is 9. And you only need about 3 of them, but 4 sounds good right about now. So we could graph these points. We got 1/3 -1, be about right here. We have 1, 0, 3, 1, and 9, 2. Okay, so from there you see the curve, and actually right now what I'm going to do is draw the asymptote right now just to have it, because you can see how the line, it approaches here but doesn't quite cross it. If I kept putting like negative numbers here, like if I tried -2, all right, I guess it messed up for a little bit. I say if I put -2, and you don't have to put this, but if I put -2, 3 to the -2 would be 1/9. Okay, so what's happening is it gets infinitely close to the x-axis without ever hitting it. So it's just the opposite of exponential functions. Let me erase some of these. Don't need those. Okay, so if we draw a smooth line connecting those points, it's going to look like this. Hopefully I make it smooth enough. Okay, so basically what happens is it levels off at x equals 0, okay, because you can't take the log of a number or a negative number, okay, and that's what the graph is going to look like. So if we state the domain and range, domain now has some restrictions. Notice how all your x's are positive and how when it gets close to that line it starts to level off. So our domain is x is greater than 0. Now our range can be both positive and negative now. So our range is all real numbers, so that changes it. And then our asymptote would be, it didn't move left to right, so it'd just be x equals 0, okay? So we graph the function state, the domain and range, and the asymptote, okay? Now, what if you want to do it without with the calculator, okay? Now, same way, if you want to do this calculator, just do 1/2 y to the x, and you just make a table and solve it. And you can do it that way, and that's fine. But if you want to use a graphing calculator, you have to use the change of base formula. So I can use the change of base formula as you can do something like this. You could put it in your calculator as, you go to y1 and plug it in as log x divided by log 1/2, okay? And this is called the change of base formula. I'm not supposed to tell you this till later, but if you want to plug in graphic calculator, check to make sure you're right. That's how you got to do it. So this big number right here always goes on top, okay, and then the base always goes on bottom. All right, and you have to put log on both, otherwise it won't work. So let's try that in our calculator. Let's clear all this out. Go to y equals and do log, what is top, x, log x divided by log, and let's just do 1/2. We can do 0.5 or 1/2, doesn't matter, okay? As long as it's all in parentheses. So then you hit graph, and you can see the graph, how it's decay and how it curls up until it, but it's not going to quite hit it. The 1/2 makes it a decay function, so that means, well, actually, yeah, decay function means it's going down. It also reflects it differently. And then we can just use some points off this table. So let's hit second table. Actually, let's go large screen. Okay. And let's look for some numbers that we want to use. Okay, so obviously 0 is our asymptote, okay, but there's some other numbers we can use, like 1, 0, 2, -1, 4, -2, and what else? You know, 8, -3. And what they don't show here is, and this is how people get messed up, they think, okay, so it just stops, it's an error. But if you went infinitely close to, okay, stop. All right, so at 1, it's x is 1, y is 0. At 0 is an error because you can't take a log of 0. But let's say if we change the table set, hit second table set, and let's change it to let's change it to 0.2. Okay, and then hit second table. Okay, now you notice that it doesn't end at just 1. You know, 0.8, 0.6, 0.4, 0.2. You know, infinitely as you get closer, you could go, you know, 1/32. You could do 0.005. Anything as it approaches 0 is going to be a value. Okay, and a lot of people get confused by this, but all they see is that last value being in the error. Okay, so don't make that assumption from, you know, those two numbers. You can have values right there that do work. Okay, they're just normally not going to input them. Okay, but anyway, let's just plot these dots and graph it. Okay, so we got 1, 0, we got 2, -1, 4, -2, 1, 2, 3, 4, -2. Got 8, -3. Okay, and we can draw our asymptote because it's not going to change. Oops, I don't want that. I want a dashed line. Okay. All right, and we can just have it curving up to that dashed line right there. So it's going to look like this. Curving up, and then we just have some arrows because it does curve up forever. It just runs along that line forever. If you got infinitely close, like 0.0005, it's going to get close to that line right there. Okay, so that would be the graph. Domain is x is greater than 0. Range is all real numbers, and our asymptote is x equals 0. Okay. All right, translating. Okay, so logs can be translated just like anything. X minus h. If you have x minus a number, it's going to move it to the right. If you have x plus a number, it's going to move it to the left. Okay, and then if you have that plus k, that's what's going to move it up, down. If it's like plus 5, it's going to go up 5. If you have minus 2, it's going to go down 2. So that's how you transform a parent function. The asymptote also changed. On the other ones, there was no transformation, so the x, it was always x equals 0. Now it is whatever h is. Okay. So if it's x minus 3, your asymptote's going to be x equals 3. If it's x plus 2, then your asymptote's going to be x equals negative 2. Okay, so remember that rule where it's in parentheses is usually the opposite. A lot of people mess that up. Okay, so what I'm going to do is use the graphic calculator on this one. You could rewrite it as 1/3 to the y and then add 3, but I think more people will be confused by that. So let's just plug it into the calculator. So let's go back to y equals, clear this out. And real quick, how I have to write this is log x minus 3 divided by log, it has to be a log on both, otherwise it won't work, 1 divided by 3. Okay, and this is a change of bears formula. You got to do both. Okay, so then you hit graph, and you can see right there, x minus 3, I should know right now, it moves right 3. And look how it cuts off right at that right 3 moment. You can see it better on the large screen, how it's going to be, that's going to be your asymptote. Okay, and let's hit second table. We see a bunch of errors. And I'm actually going to change my table set back to just 1. Okay, so we got 4, 0, 6, negative 1. So I'm going to graph some of these. Let's see here. 4, 0, 6, negative 1. What else we got? Any other good ones? I'm just going to graph negative 10. What was that? Negative 10 and negative 1.77. Okay, so we graph those. And first, actually, I'm going to always draw my asymptote first. I think it's easier. We know it's going to be at 3 because that's where the error occurs at and where, it moves right 3. So I'm going to draw that first so I know where it approaches. And then I'm going to graph these points. So 4, 0, 5, so 6, negative 1, and 10, negative 1.77. I'll just draw these 3 points and have it approaching that, but it never quite hits. Okay, as long as it's close, it'll be fine. The main thing I'm looking for is that it approaches the asymptote in a few points to make it look like what it's supposed to look like. So the domain now changes. Domain is now x is greater than 3. Okay, because all the numbers have to be bigger than 3, otherwise it's error. You have log of 0 or negative, which you can't do. The range is all real numbers, doesn't change. And now the asymptote is x equals 3. Okay, we should be able to tell that just by what makes this go to 0. Okay, we can set that equal to 0 and solve. Okay, let's do another one. Now, how I'd plug this in is I'd have to do log x plus 1 divided by log 4, because you always put the base on the bottom and this part on top, and then you just hit minus 2 at the end. So let's put that in a calculator. Okay, we'll do log parentheses x plus 1. Oops, delete that. Let's go back. Okay. Let's go x plus 1 divided by log 4. Close the parentheses. That's important. If you don't close parentheses right there, it'll mess up. And then minus 2. Okay, and then hit graph. Okay, and you can see from there what the graph looks like. Okay, x plus 1, what makes that go to 0? Negative 1. You can see from there, right here, that's our asymptote. That's where it starts to cut off. Okay, so let's make a table and find some points. You can see negative 1 is your first error point. Now always be your asymptote as your first error point. So we got 0, negative 2. 0, negative 2. We have 3, negative 1. What else do we have? No other really good points. Let's do 7, -0.5. That seems like a decent point. Okay, so again, draw your asymptote first. I know we haven't officially put it, but we know it's -1, so let's put that first. That's bad. Make it straight. There we go. Okay, and then we can plot our points. 0, -2, 3, -1, 7, so 10, 9, 8, 7. Oops, I'm going backwards. Hold on a second. So 0, -2, 3, -1, and 7, 10, 9, 8, 7, -0.5. So you can see from there how it's going to curve down and approach the asymptote, but not quite hit it. And then this one is just going to go up on that path, okay? And that's what it's going to look like. Domain now is x is greater than -1. Okay, because that's what makes it go to 0. The range is all real numbers, doesn't change for this one. And x equals -1. So the main thing I want you guys to be able to do is, most people are good with the calculators, but domain and range and asymptote, people are struggling. So make sure you understand the structure of the problem and how that changes it. Okay. Also understand, like if they ask you for a transformation, the +1 moves it left 1 and the -2 moves it down 2. Okay, from the parent function. Okay. All right, this is the last question. State the asymptote. Again, focus on what makes that go to 0 and you'll find your asymptote. If you have any questions, email me, and that is it.